My friends, if you suffer from GLBP anxiety, or know someone who does, first off, I want to tell you you've come to the right place to get a cure for that, and secondly, you are not alone. This is the most misunderstood protocol, I think, in any course I've ever created, and I don't mean misunderstood by me. I have people come to me or email me after, it's like, oh, thank God, I never really got GLBP until you explained it, because frankly, a lot of the explanations I've seen really aren't that good. And trying to learn it from a CISCO PDF or something that's the equivalent, if you're just looking at the commands, it tends to bounce off your head. And I know that because it bounced off my head when I started studying this for the IE lab a long time ago. So I always like to tell people, there's a learning curve for everything and everybody goes through it. And there's definitely one with GLBP. Now, the even better news for you is that I've actually spent the last couple of days creating some new labs that I've never had in an NP course before to give you an even better understanding of exactly what's going on. So these particular labs are going to go into more detail than HSRP and VRRP simply because there are more details to cover. But the other thing I want to mention before we dive in, if this is the first time you've seen it, I'm not saying this to scare you. You can learn it. I learned it. Everybody can learn it. The key here is we're going through the theory. If it's bouncing off you a little bit, hang in there because once you see it in action, you'll know exactly what's going on. The basic operation of GLBP, we're going to do a walkthrough here on the board in this video, and you'll see it's simple. It's when you get into the AVGs and the AVFs and the weights and the priorities and the thresholds that things can get a little tricky when you're just trying to read it by, learn it by reading it. So seeing in action will definitely help. Now I will shut up in one way and get back to teaching. Why are we going through all this with GLBP then? HSRP is in operation everywhere around the world. So is VRRP. What do we care? Why do we need another protocol for this? Well, as we've seen firsthand in the labs in the last couple of sections, while they're good, solid protocols for router redundancy, load balancing with them, it's more of a workaround than a native behavior. It's almost like we're tricking the protocol. The other thing is it creates a little more work for us, and we're not lazy, but there's no use in doing extra work if you don't have to, because we've got to split up the default gateway IP addressing with those, right? We've got to get some hosts pointing to one gateway, some hosts pointing to another, and the more kind of things you have to do like that, the easier it is for an error to creep in. That's just the way it is. The odds go up. So when you're dealing with something called the Gateway Load Balancing Protocol, it's a pretty good guess that this protocol was developed with load balancing actually in mind. It's a native behavior of the protocol. Now, just one quick note, this is not suitable for use in the dreaded multi-vendor environment because it is Cisco proprietary, can only be used on Cisco routers and switches. Now, one of the few similarities we're going to see has to do with the router group and the virtual router concept. I'm talking about differences and similarities between GLBP and the protocols we've looked at so far. By default, GLBP allows every router in that group to handle some of the load, and the default manner is in a round-robin manner. There are others. We'll take a look at those later in the section, but we love that because otherwise, by default, we got a primary router handling the entire load, and the standby routers, they're just standing on the side waiting for the active to die so they can have something to do. That's not what they're really waiting for, but they are ready to step in, but before they step in, they're not doing anything. Well, another reason that we really like GLBP is that the hosts think they're sending all of their data to a single gateway, but actually multiple gateways are in use at one time. That's not the part where that crazy about. We might not care about that, but we do care that for that reason, GLBP allows us to configure one single default gateway on all of our hosts. None of this, 50% of the hosts are going to hit this address, 50 are going to hit the other one. I don't mean to make that sound so horrible. It's not a terrible thing to do, load balancing with HSRP and VRRP, but at best it's an inexact science, and at worst it's just a real pain in the butt. Now, what we're going to look at is how this protocol works. And what we've got here, we've got 3 hosts sending an ARP request from the MAC of the virtual router. And just as with the previous protocols, we do have the virtual router concept with GLBP. Now, the router with the highest GLBP priority is chosen as the active virtual gateway, the AVG. we have AVGs and we have AVFs, and we need to be very clear on what each one does and how they're chosen, and we will make that very clear in this set of videos. Now, those AVFs, they're the routers that are receiving and forwarding traffic received on these virtual MAC addresses, because what the AVG does, it assigns a virtual MAC address to every router in this group that can potentially act as an AVF, an active virtual forwarder. And then it's that router, the AVG, that sends ARP responses back, and it contains virtual MAC addresses, not the actual MAC addresses of these routers in the group. Now, the AVG is also in charge of assigning, like I said, the virtual MAC addresses. Here is the format for the virtual MAC address. It's always going to begin the same, 0007B400. Following that, you have an XX and a YY. XX is the GLBP group number, and YY is the AVF number. And the AVF number is assigned by the AVG. You know, the first one it gives out, of course, is going to be 1. The second one it gives out is going to be 2, etc. And I'll show you in a few minutes, once we get a lab started, how to view those numbers. Of course, since these are part of a well-known MAC address, and it better be well-known to you before you take the switch exam, these are in hex. So again, it's 0007B400 and then XXYY. XX being the group number and YY being the AVF number. Now, I know you're already thinking, what happens if they all have the same GLBP priority? Well, in that case, the router with the highest address becomes the AVG. Now, in the following illustration, and this is an illustration because in our lab we're going to have 3 routers. MLS4 is the AVG in group 1, and you can see the MAC addresses that it's assigned. They all begin with 0007B400. Then the next part, the XX, is 01 because we have GLBP group 1. And then, let me bring that up so you can see it. There we go. And then, of course, the ending of it is just the number that was assigned by the AVG. So we saw the requests coming in. And the AVG answers those incoming ARP requests with ARP responses containing the virtual MAC of one of the routers in the group. And I know I've said that at least twice already, but it's a really important concept to remember. These hosts are never going to see the actual MAC addresses of the switches in this group, only the virtuals. Now, our GLBP deployment again here is using the default load balancing technique of round robin. So the first ARP response will contain the virtual MAC of MLS 1, then the next one 2, and then the next one 3, and then the next response, which is not shown here naturally, would contain the virtual MAC of MLS 4. And then it just kicks around again. You know, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's just the way it goes. Now, should that AVG fail, of course, we got to have a backup plan. And we will have a router that is pre-chosen as the standby AVG. And that, of course, is the router with the next highest GLBP priority in the group. And if that's a tie, as you would expect, the router with the next highest IP address would take that role. So here, that would be 3 if we used our usual numbering system. You'll see that in the lab as well. Now, if any of the AVFs fail, there's a problem, because then we got a virtual MAC out there, but we don't have anybody to handle it when hosts send data to that virtual MAC. Well, what happens is another router steps in and it says, I'll handle that load. I will take the traffic for destined for that MAC address that was assigned to that router that is now down. We're going to see that in action as well. Now, GLBP routers use Hello's multicast to 224.0.0.102 to detect whether other routers in the group are available or not. They're always talking to each other, and believe me, I mean always. Now, let's talk about those assignments for just a moment and how they get done. By default, again, as I've mentioned a couple of times, GLBP is going to load balance in a round-robin fashion. And that's where an ARP request comes in. It just gets a response from the next virtual MAC address in line. We can also use weighted assignments. And there, where the higher the assigned weight, the more often a particular router's virtual MAC will be sent to a particular host. Now, you might have a situation where a host needs the same MAC gateway address every single time it sends an ARP request or every single time it sends data. So in that case, we have what we call host-dependent balancing. We're not going to get into host-dependent balancing, but I want you to know what that is. And again, if a host needs to send data to the same virtual gateway every single time, that can be set up. Now, our lab, I'm going to go ahead and show this to you now, and we're going to hit the lab in the very next video at the beginning of it. But it's going to be a little bit different than the previous HSRP and VRRP labs, because here's a hot one for you. GLBP doesn't run on a whole lot of Cisco switch platforms. So what I'm going to do is use Cisco routers in this lab, some new ones we got in that do run GLBP. This is a good way to show you also that it runs the same on multi-layer switches as it does on routers. I'm going to use the same multi-layer switch icon and names as we've used in the previous labs. I just want to mention to you that here, each physical device is going to be running the IP address shown on its fast Ethernet 0/0 interface. So if you break open some switches in your home lab, and the GLBP commands are returning, gee, I don't know what you're talking about, unrecognized command. That's why. It simply does not run on that many switch platforms, but it runs on most router platforms. So that's what we're going to do here. We will start with that config at the beginning of the very next video. See you there.